Loud noise. Noise. Noise, noise, noise. What do you want me to do? I can't do anything. Eat my ass. Alright, so let's do some packet tracer. Alright. So let me get this ready. This should be available. What do you mean it's not? Why not? What is this? Alright, one sec, I'll be back. Sorry about that. Alright. Now, let's do some packet tracer. Okay. Let me just change this just a little bit. No, okay, no. Alright. Packet tracer. So what is our task? Our task is .2.4.5. Is it on Netcad? I don't know. I don't know. On this, let's go fiber optics. 1.2.4.5. This activity will explore how Packet Tracer serves as a modeling tool for network representation. This is exact. I guess this is what we have to answer from what you said. Okay. We open. Oh. Can I not? Okay. A network model in this activity incorporates many of the technologies that you will master in your CCNA studies. It represents a simplified version of how small to medium-sized business network might look. How a small, okay. Feel free to explore the network on your own. When you're ready, proceed through the following steps and answer questions. Step 1. Identify common components of a network as represented in Packet Tracer. The icon toolbar at the bottom left hand corner has various categories of network components. You should see the categories that correspond: intermediary devices, and end devices, and media. Connections category with the lightning bolt represents the network media supported by Packet Tracer. There is also an end device, an end devices category, and two categories specific to Packet Tracer: custom-made devices and multi-user connection. B. List the intermediate devices category. C. Without entering into the Internet Cloud or Intranet Cloud, how many icons in the topology represent endpoint devices? Only one connection. Is this... What do we have to... Oh, is it the same questions? Okay, that's the same questions. J. So. It says here, the icon toolbar at the bottom left and corner has various categories of network components. Alright. So, what do we have? Components, connections, miscellaneous, multi-user, networking devices, switches, hubs, security. Guess that's how it looks like. Cool. What is this? It's another network switch. Central server. Okay. You should see categories that correspond to intermediate devices and devices. Intermediary. End devices, network devices. It's a PC. Is it these? Network devices? I don't want router 0. Oh. What is this? Oh. Okay. So I'm going to assume it's network devices, which is intermediary. I mean, we can look that up online if we're not too much of a dumbass as to what that means. Person who acts as a link between people in order to try to bring about agreement. Devices. Great. Fucking, you're gonna tell me now? Alright, I figured. So if we used common sense, it's basically the beginning and what connects to what. So what do we have? We have routers, switches, hubs, wireless devices, security, and a WAN emulation. So let's do that. Routers. Switches. Hubs. Wireless devices. Security. And WAN emulation. Next, it says, without entering into the internet cloud or intranet cloud, how many icons in the topology represent endpoint devices? Only one connection leading to them. This is the topology. I mean, based on what he said in the notes, and what topology is. Two types of topologies: physical and logical. Physical network and where devices are. Shows devices connected to network and addressing info. Okay. Does that show? It's alright. Here. Shows physical network and where devices are, and shows devices connected to a network and addressing info. So knowing that, go back to keyboard, we can see that this one has 4 end devices and a central server, be it that, yeah. So there's 5 in central. There are, I mean, if we go to end devices, what do we have? End devices in a home, smart city, power grid, end devices. Generic computer, laptop, generic server. What is this? Oh, printer. Interesting. TV, wireless tablets, blah blah blah. A sniffer. One sec. Okay, let's get back to it. So we see that in central, we have a server and 4 PCs. Then we also have in the branch sniffer. Let's delete the sniffer. We have a branch server, a laser, a smartphone, a laptop, and 2 more computers. Only one connection leading to them. Technically, the phone, it indicates as an end device is the IP phone, but it's connected to 2. So I guess this would be an endpoint regardless. Okay, so we see that there's 4 in central, 5 in central. There's 1, 2, 3, 4, 5, 6, 7, 8 in branch, and in home office there is 1, 2, 3, 4. So 9 plus 8 is 17. So there's 17 total devices. So without entering how many icons, there are a total 17 endpoint devices. Just to make sure I'm not a moron. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. Next, without counting the two clouds, how many icons in the topology represent intermediary devices? From what we can tell, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. Are a total of 10 intermediary devices. Give me 1 second. Just gonna make a few things clear. Hello. Yes. If I had to guess. Anyway, let's get back to it. How do I see only chat? Is that a thing? Is that a possibility? There we go. Oh no. Okay. So if we go back, Facebook. Okay, wait, where was I? The fuck? There are a total of 10 intermediary devices, 13. That's correct. How many end devices are not desktops? And we have 1. Would this is this considered a desktop? No. Well, I don't think it's a desktop. I'm going to assume it's not. Oh. Oopsie daisies. Okay. So, in total, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of the end devices, DND devices, right. Ten of them are not desktop computers. Okay, how many different types of media connections are used in this network topology? Media connections. Let us see. So, media connections. Copper straight through, copper crossover, fiber, phone. Wait a second. Media connections. Okay, so there's serial DTE. There's serial DTE. There's copper straight through. What is this connection though? Wireless. I guess. I mean, does it seem like there's wireless at all? Does that seem plausible? Console, copper straight, copper cross, fiber, phone, coaxial. I'm just gonna say wireless because from what I can tell, there's straight through, wireless, and serial. I mean, even in the notes, what he gave us. I mean, copper cable usually serial looks like a weird lightning bolt, which I mean is this, but then there's for LAN connection, but there's no wireless connection. I mean, unless it's common sense, I'd assume it's common sense. Well, whatever. Okay. Is this still called test stream for school? It is. Fuck. One sec. I need to change that. Packet tracer homework. August. Yeah, whatever. There you go. Okay. Did it not save? Well, it should change. There it is. Oh, okay. Who is watching us right now? Who is watching? Who's watching, get answer. Alright. So, where was I? I was blah 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 here. We said how many different types of media connections? Well, we had decided on 4. The wireless straight through, no, 3. Wireless straight through and serial. So, there are 3. Alright, step 2, explain the purpose of the devices. Alright. In Packet Tracer, only the server PT devices can act as a server. Desktop or laptop cannot act as a server. Based on your study so far, explain the client-server model. Okay. Well, if we take a look at my notes. Hello, Max. Here to take some answers. Let's move that so we can see. All right. Client. We said, what is? Explain client server. Okay. Clients and servers. So I have written down, which might be completely different from what everyone else has. I mean, you can just have it play in the background, you know. Motivational. In any case, in a network, we have clients and servers. So clients are computers, devices that are required info and service. And a computer, which is, no, sorry, yeah, the server is a computer or device that gives out the info. So what is this saying? Explain the client server. Okay. Peer-to-peer and client server. Dedicated server that only runs a server. Okay. Keyboard. Alright, so from what I can tell, the client server model is a devices set up for a specific task. The server's job would be to send data requested by the client, and the client would only be there to receive. I cannot spell. Give me a second. Is to receive. I didn't ask to know how to spell that. Retrieve said data. You see, you might say that, Max, but I mean, granted, this is just a webcam. But if, let's say, we had our circuits, I'd bring out this bad boy. I'd bring a DSLR. Only on YouTube because it's easier for people to see it. Because if it was on Twitch, then they'd have to make a Twitch account. While on this, they already most likely have a Gmail, so they just have to link it to YouTube. But yeah, I mean, I can't only use this. I mean, it goes pretty far. See my nasty ass fingernail. But this would only be to show up close, but then I'd use the webcam. In any case, I need to get a separate numpad because this weird hybrid board doesn't work. Yeah. Well, I mean, there's a lot here, especially a lot of this stuff is pretty expensive. Well, pretty expensive. But yeah, honestly, I had most of this already lying around, so I said might as well. I think this is fine. I might look at it after. Maybe. How much of there is there? There's too much. 4 pages is too much. Alright. So let's go back to Packet Tracer and see what else they want me to do. List at least 2 functions of intermediary devices. Oh. That is not for us. Alright. 2 functions. Do we even have the word intermediary at all? Oh, we do. Network hardware needed to connect together or forwarding. Routers, LAN switches, blah, 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 blah. Regenerate data. Maintain info. Aha. Copy paste, like we always do. So what I wrote for intermediary devices, or basically all the stuff you mentioned in class, was that it regenerates data in a signal. It maintains info about pathways for data to travel, and then it notifies errors, and it classifies said data info according to priorities. QoS, quality of service. And 5, permit or deny data. I wrote here routers, multi-layer switches, routers and switches, but basically this is kind of what they do. So I'm going to say that they regenerate data and signals. These, let's go back. These devices regenerate data and signals and also notify of any errors at the end device or of the data itself. Okay. List at least 2 criteria of choosing a network media type. Choosing a network media type. So, different types of media. So, it's the one right after. Thank you, Boris. Copper, fiber, wireless. Choosing a network media. So, basically, from what we can tell, I mean, if we look at one quick, cheap, and shortest distance, what I have enclosed in the box is, for me, was what seems to be the, I guess, the con of each one. So I guess for copper, it would be shortest distance, fiber would be expensive, and wireless transmission is affected by the environment, which, I mean, I guess they all have different cons, but I guess we can say his criteria would be price, speed, and quality of transmission, I guess, in a sense. So I you know what, I think I like that, so I'm gonna write that. So it says list 2, so I guess we can say criteria for choosing a media type would most likely be dependent on either the price or of the medium or the speed. Price or the speed of said medium. I'm going to change that. Or the speed of said media. This makes me feel uncomfortable. This also makes me feel uncomfortable. All right, there you go. Let's go to number 3. Yeah, okay, latency. I mean, see, that's the thing. For copper, the shortest distance, implying that, I mean, depending on what the device you use, I mean, if you compare a normal copper switch compared to a fiber switch, I mean, what has more latency? I mean, it's dependent on the device. But if we look directly onto the media itself, of course, light traveling compared to electrons in a copper wire, I guess you can say that it's... I guess you can say that copper has more, but I mean, in this case, obviously it's based off our notes, but at the same time, I mean, I guess we can say that's more of, I guess, speed, in my opinion. One sec. Just want to make sure that I'm not too loud on the stream. I'm going to listen to myself, because I see that on OBS, my mic is hitting the max each time, and I want to make sure that I don't kill anybody, but at the same time I sound fine. Fucking iPhone piece of shit. God. This thing costs fucking $50. Short distance might be faster. Over shorter distances might be faster because of the muxing required for fiber. I mean, you can say the same thing for copper. I mean, because in theory, anything, if it's, oh yeah, fiber is faster. It makes sense. Light travels at what, 300,000 kilometers per second. Obviously we can't base it entirely off that, but I'd assume that copper would be yes, fiber is faster, but depending on what you want to do, if it's really short distance, why do you need copper why do you need fiber when copper is right there? And even better, what if it's not obstructed by anything? Just go for wireless. Of course, it depends what you want to do, how far you are, if there's anything there, and what's your budget. So, but we shouldn't discuss more as to who has the bigger balls. So, let's just get to it. Explain. So, step 3. Explain the difference between a LAN and a WAN, and give examples. So, LAN or crying out loud. More definitions. NICs. 2 types of topologies: LAN, WAN. So we got a local area network and a wide area network. Here. So LAN, interconnected devices in homes, schools, office buildings, etc. And it's most of the time administered by a single organization or individual, and they control security and the control policies of said network. LANs also provide high speed bandwidth. High speed bandwidth. Brackets bandwidth. So, compared to a WAN, which is connected LANs over wide areas, so owned by multiple ISPs, and it's slower. So, wide areas, let's actually make a note of that. That wide areas are global from large area to the next. Etc., etc. So WANs are global, as in wide area network, and LANs are local, hence local area network. So what we can say for the question, which asks us, what's the difference between both? We can say that LAN is designated for local networks like homes and offices, LANs offer high speed, high data transfer speeds, and are administered by one by a person within said network not by ISPs. A WAN is for transferring what the fuck? Data all around the world. Like the internet. These, in this case, WANs are controlled by ISPs. So yeah, I think that's good. In Packet Tracer network, how many WANs do you see? Would an intranet be considered a WAN? Networks inside networks, an intranet, private connection to LAN. Computer account at Dawson network. So, yeah, you know what? I guess I would say that these two are the WANs, be it that they're connected through serial, but they're outside of each of these boxes, which, I mean, each of these boxes probably indicates that each are individual LANs. So there are a total of 2 different WANs. How many LANs do you see? Well, we saw that there are 3. There are 3 different LANs. Internet in this packet tracer network is overly simplified and does not represent the structure and form of the real internet. Briefly describe the internet. Oh, my dog. My dog is barking. People are at home. I'm going to mute my mic for a second. Give me a second. I'm back. I know, I wrote te. Fucking kill me. Around the globe. It consists of... Hold on one sec. It consists of... large fiber cables in the ocean, sending data back and forth between continents. Oh god. You get my keyboard. Between continents and fiber or copper cables on LAN connecting places together. Common ways a home user connects to the internet. Well, common way would be through devices such as computers, cell phones, and tablets. It says, what are some common methods that businesses use to connect the internet in your area? That businesses use to connect to the internet in your area. Is that a trick question? Oh. I guess not. I guess it's probably this. Business connections, medium or large networks, dedicated lease lines, or Ethernet WAN. Oh. I don't think this was what the right question was asking. So it asks, what are some of the common ways users connect to the internet? Well, it's basically asking these methods. So let's write that. So through different connection through different methods like DSL, cable, cellular, satellite, or dial up. I did not spell that right. No, I did. Dial up. For businesses, from what we see in the notes, we realized that they connect through dedicated lease lines, Ethernet WAN, DSL, or satellite. So for businesses, they will connect through dedicated lease lines, Ethernet WAN, DSL, or satellite. Alright, challenge. Now that you have had an opportunity to explore the network represented in packet tracer activity, you may have picked up a few skills that you would like to try out, or maybe you would like the opportunity to explore the network in more detail. Realizing the most of what you see and experience in packet tracer is currently beyond your skill level, here are some challenges you might want to attempt. Do not worry if you cannot do them all. You will be packet tracer master user and network designer soon enough. What is this? Hold on. Can I? That is awkward as fuck. What is this? What is this? So add an end device to the topology and connect it to the LANs with media connection. What else does the device need to send data to the other end users? Can you provide the information? Is there a way to verify that you correctly connected the device? What is suggest scoring rubric? Oh, that's not for me. Do I even need to do this? In all honesty? I mean, I guess we could try. So let's say it says add a device to the topology. So I'm gonna add a computer, and then this. Oh, and then we're gonna connect to. All right, 3. What is this? Oh, 4. Down. I need to configure my computer to there. It did it automatically, so now it sees the IP. Yeah. Because if we go to the home desktop, just the inkjet. What is this? we could see that it's a 101. I mean, in this case, he gave it a static IP at with a specific DNS server with nothing. I just gave it that, so I just did it automatically using DHCP, which is fine. I mean, yes, it will be, Evan. Yes, it will be. Okay. Can you provide the information? Is there a way for you to verify that the correctly connected device? So, I guess what I could do is also do it manually. So, I give it 192.168. Huh. Well, it seems to work. Add a new intermediary device to one of the networks and connect it. 1 second. Alright, well, sorry for the long pause, but all of this challenge to me doesn't seem like I could submit it in any way. And I'm too dumb, so I just gotta look over my stuff, see I'm not much of an idiot. My devices are those WAN emulation. Okay, there are 1217 endpoint devices. Okay. These devices regenerate data. Why is it capital R? And signals, and also notify. I don't know why it's capitalized. Any errors at the end devices or the data itself. Will also notify of any errors at the end devices. Criteria for choosing media type would most likely be dependent on either the price or the speed of said media. LAN is designed for local networks like homes and offices. LANs offer high data transfer speeds and are administered by a person within said network, not by an ISP. Or ISPs, because it's plural. A WAN is for transferring data all around the world, like the internet. WANs are controlled by ISPs. Total of 2 WANs, 3 different LANs. Connects everyone around the globe. It consists of large fiber cables in the ocean. In the ocean, sending data back and forth between continents, and fiber combos on land, connecting places together. What's the different one? So I said DSL, cable, cellular, satellite dial-up, and here dedicated leased lines, Ethernet, DSL, and satellite. Okay, so this seems good. Oh shit. Just to make 100% sure, because I don't know how it works, because I've never written anything on I'm gonna copy everything onto a Word document. Shit. Two hours transferring. Good to know. And the internet. Needs a space. Okay. Honestly, fucking proofread my garbage. Jesus Christ. This is embarrassing. Oh. Jesus. Internet. No, just in here. Okay, so let's download onto my desktop. Is my stuff saved? It is not. Hooray. Of course it's not. That's what I thought. Okay. There is a total? There are a total. There is a total. End devices. Endpoint in one word. Well, good to know now. Use Word to proofread my garbage. And then criteria for choosing media. LAN. Let's stay consistent, I guess. There is a total. There are 3 different LANs. I mean, it sort of proofreads all this for me. What the fuck? Oh, I did cut. That explains it. Okay, well, I'm pretty much finished. So I'm going to end the stream here. I don't want to embarrass you more. I don't embarrass myself more with my terrible grammar. But yeah. So that was the first homework, I guess. Let's see with what Boris thinks of it. If it's not too much giving away the answers. But yeah. I think it's pretty good. Alright. See you guys later.